Buongiorno a tutti da SecurityCert anche stamattina. Lo so che siete abituati a vederci la domenica più che altro con Security Break, ma stamattina siamo qui per farvi compagnia da un evento un po' particolare che il nostro buon Fabio è riuscito a diciamo rimediare, tra virgolette, no? Ci siamo proposti, eccoci qui per fare la telecronaca, chiamiamola telecronaca, per portare sul nostro canale live la conferenza di Bsides 2023. Già ti chiedono le maglie, io vedo già una chat molto attiva. Buongiorno di DOS. Allora, oggi ci ospita l'hotel Best Western Universo Roma, giusto?
Sì.
Io qua sono un po', come dire, mi sento un po' un pesce fuor d'acqua stamattina. E con me c'è il buon Claudio Fostox.
Ciao ragazzi.
E ovviamente il capo. Ringraziamo innanzitutto sia la nostra regia, che oggi davvero d'eccezione è stata fantastica nell'aiutarci a sistemare tutto quanto, ma soprattutto ringraziamo l'organizzazione dell'evento e tutti gli sponsor che ci hanno un po' permesso di essere qui. A breve inizieranno gli speech, inizieremo con un'introduzione del nostro ormai caro, perché lo aspettiamo in live da un po', Agostino Benish Panico, quindi inizierà la sua introduzione, vi lasceremo ovviamente godervi la conferenza in santa pace e ci rivedremo negli intermezzi per commentare un pochino e magari fare 4 chiacchiere con gli intervenuti. Credo non ci sia molto altro da dire per la nostra introduzione, no. Ragazzi, io sono un po' emozionato.
Io pure, io sono curiosissimo.
Lo siamo un po' tutti.
Veramente è un'esperienza particolare per me, devo essere sincero, è la prima volta che mi capita, penso anche per voi.
Sì, confesso, insomma, il primo Bsides.
No, al di là del primo Bsides, per me è proprio un'esperienza particolare essere qui, fare questa sorta di, chiamiamola animazione, sì, dell'evento, no? Fare un po' da canale ufficiale per l'evento, anzi ho un grande piacere a farlo. Tra l'altro alcuni sponsor d'eccezione, cioè, al di là dei nostri amici di Pwnix che anche oggi saranno presenti alla conferenza, vedo nomi importanti, vedo Sababa Security, vedo Hack5, insomma nomi comunque della realtà cyber abbastanza importanti, della realtà security, sì, molto affermati, come dire.
Sì.
Direi che siamo anche pronti per iniziare, vedo le persone che iniziano a prendere posto, vedo Agostino in prima fila, il nostro Benish sul podio. E che dire di più? Io mi aspetto una grossa partecipazione dalla nostra chat per tutti i presenti. Mi dispiace non avervi qui perché è veramente un'occasione particolare, cioè queste fiere, diciamo, questi eventi, queste conferenze sono sempre un'occasione per condividere, per fare un po' di rete, per conoscerci.
Assolutamente sì, anche perché col lavoro che facciamo e soprattutto il mondo dove siamo, la condivisione è proprio alla base di tutto.
Esatto, sono d'accordo. Poi come ci insegni tu, no? Nel lato blu, condividere gli indicatori.
Assolutamente, quello sì, cioè io faccio, come dire, del gioco di squadra quasi un mantra, assolutamente, con i vari gruppi con cui lavoro, e questa è, come dire, la realizzazione massima proprio di questo gioco di squadra.
Perfetto. Fabio, vuoi dirci? Esatto,
ne fa esperienza tutto quello che è diventato SecurityCert grazie alla condivisione.
Grazie anche alla nostra community che insomma appunto, continua ad allargarsi, e vi invito ancora ad allargare questa community, a contribuire a questa condivisione. Fateci conoscere, fatevi conoscere e soprattutto, ecco, cerchiamo di, come sempre, di aumentare la consapevolezza di tutti. Vuoi dirci 2 parole che esulino un pochino dal concetto di security e siano un po' più, chiamiamole advertising, come dire, hai fatto un gran lavoro per essere qui oggi?
Sì. Diciamo, il segreto è stato sfruttare la mia amicizia con Agostino. Come sempre, tutto alla base.
Stiamo iniziando, scusami.
Stiamo iniziando. Con piacere lascerei la parola
ad Agostino.
Ad Agostino.
Guys, Audio AV is good? Okay, nice. Okay, good morning everyone and welcome to Security Bsides Roma chapter. I'm really happy to have you here and I'm really excited because we have a lot of good content today. The first thing that I want to do is thank our sponsor. Without them, there were no Bsides actually. So first of all, I would like to thank our gold sponsor, Sababa Security, that provide the lunch. So if you don't like the lunch, those are the guys. Then we have Moveats that provide the location. If you don't like the location, you can pick on them. Where are them? Yeah, Eduardo, Lorenzo back then. After that, I would like to thank Unlock Security for the beer. Again, if you don't like the beer, you can pick on them. Where is Francesco? Yeah, Francesco is there. Then I would like to do a special thank to SecurityCert that is in the back of the room. They are taking care of the streaming, as always. If you don't like the streaming and if you don't like the recording, they are the guys. I'm not doing anything, just providing information today. And the other company that I would like to thank is Ponix. Ponix is an Italian-based company that is providing the CTF platform for today. So if any of you is playing the CTF and you don't like it, you can pick on them. I would like also to thank Hack5 because they provide some voucher as a CTF price for today. So we have the first prize from Ponix, that is the early subscription for the entire team that is going to win. And then we have the voucher for the second place and third place of the CTF. So I would like really to thank them all. And without them, we had some issue with this event. So why we are doing Bsides here in Rome after 5 years? I would like to provide some background information. 5 years ago, we started the event here, and there were no events in Rome. We started it to share information, to build up community. And community is not just being part of an association, it's helping each other. And what I'm noticing during the last couple of years, that people are not actually helping each other a lot. That's why I decided to start the organization again for Bsides in Rome. And we're going to have Bsides also in Milan in July. I'm providing some information about that at the end of the meeting because we are going to have a big event in Milan in July. And doing that, I really hope that this conference can be the cornerstone on a community behavior, behave each other better, and not just picking on each other. That is something that I'm noticing over and over the different communities. And with this closing, I would like to give the floor to our first speaker. We're supposed to have two, but actually one of them is sick. Actually, Giorgio is sick, right?
Yeah.
Unfortunately. And a fun fact about these two speakers. I know Giorgio since last year. I didn't know Dimitri for this conference. And those are the only two speakers that I wrote down the wrong surname. And no one noticed until 1 week before the event. They sent an email and say, probably you wrote down the wrong name on the conference agenda. Really? And this happened before also with Giorgio, because it's not the first time. That's hilarious sometimes. So Dimitri, come here. Oh, ce la facciamo. Ce l'hai qua. C'è tutto qua.
Grazie.
Puoi parlare?
Funziona? Good morning, everyone. Welcome to our talk. Well, to my talk, since Giorgio is not here anymore. Io non vedo. Agostino? Sta giù? Non vedo qua sotto il coso.
Vai, F5.
Ah, ok, grazie.
Vai, prova.
Okay. Good morning, everyone. Welcome to our talk, How to Get Away with Malware. I am Dimitri. I am a security consultant and researcher at Segforce. I work for, I am a penetration tester and red teamer, and my research field is malware development and also OS internals. This talk should have been done with two people, so the research has been done with Giorgio, which is unfortunately is not here because it's sick, so I will present him anyway because I think it's worth it. So Giorgio works at CNIT and is a professor at University of Tor Vergata, and he does penetration tests, malware development, and is also a trainer of cybersecurity. During this talk, we are going to show you some techniques used by security products to analyze binaries and detect if they are malicious or not. And then we will show you some techniques used to bypass those measures to actually execute our malware. Let's start with some basics. So static analysis is a way of analyzing a binary without actually executing it. And this kind of detection is the first step that any antivirus does when a new binary has to be analyzed. And a trivial way of doing this is using hashes. This basically works on the community. So there are researchers that analyzes malwares and then collect the hashes of malwares seen in the wild. And after they add them to the database, and antiviruses can just query them and check if the hash of the file that they're analyzing is the same of some hashes of malicious software. Something a bit more advanced and smarter is pattern matching, which basically allows antiviruses to define some rules, and so those rules will be applied to the pattern matching engine, and if those rules are true, the binary will be flagged as malicious. It's worth mentioning also key imports and strings because those information may leak some behavior of the process, some content of the binary. And for example, if we have a binary that is importing just virtual alloc, write process memory, and create remote thread, it is likely that this binary is probably going to inject something in memory. And so probably the antivirus will think that it's worth analyzing it further. Sandboxes are a way of are tools for dynamic analysis. And the purpose of sandboxes is to create an emulated environment or a virtual environment, depending on the sandbox, and executing the binary, trying to analyze, basing on its behavior, if this binary is malicious or not. This kind of tools have some limitations because since it's a virtual environment, they might not implement all the stuff that are that you can find in a real operating system, for example, NUMA functions. And also, they have limited resources, hardware resources, so they cannot run indefinitely in time, and they cannot also provide too many resources to a binary because they are not meant to be a complete operating system, but it's just an emulation of it. And more interesting part of dynamic analysis is behavioral detection. And behavioral detection is like the trend now because it allows to analyze what is happening inside the system. And so the binary is like all the system is analyzed, and the binaries that are the antivirus think is suspicious are then analyzed or blocked depending on which is the action that the antivirus decided. So behavioral detection is based on analyzing the events that happens inside the system and then trying to correlate them to try to understand if those events, the sequence of the events, might lead to something that is malicious. And it's worth mentioning also for .NET that we have ETW and AMSI that are two tools provided by Microsoft to give visibility of what happens inside .NET processes to security products. And so basically security products can like register them to AMSI and ETW providers and then get the information of what is happening inside .NET processes. Another very interesting part of behavioral detection is the part that runs inside the kernel. So security products can run, can like write drivers that can interact with the operating system at kernel level because Microsoft provides some tools to analyze what is happening from the kernel. So the most important stuff are like kernel callbacks that allows you to get notified when a new process is created or when a new thread is created or when an image is loaded inside the process. And this is very helpful for an antivirus because it will detect at a very early stage that the new process is created. And so they can, for example, inject their own DLL inside the process to analyze it. And then mini filters are used for I/O activity. And they are very useful for example, understanding what is happening inside the file system. And they can be also applied for like ransomware detection and maybe response, because you can analyze everything that is happening in the I/O of like the operating system. Hooking is a user-based technique that is used by basically most of the antiviruses because, and EDRs, of course, because like the kernel doesn't, like Microsoft does not provide all the like tools and all the capabilities to understand everything that is happening inside the process. So some events might be overlooked. And so, for example, if we change permission of the memory area, like that event cannot be caught by like a kernel callback. So there is no way to understand that we changed the memory area of the process without hooking the function that is doing that. So, for example, we can hook anti-protect virtual memory, which is the last function that is called before actually calling the syscall, or we can also like hook all the APIs that are on top of it. And to like the principle of hooking is really simple because we find the function that we want to hook, and then we get the prologue of the function and we override it, patching the function so that we jump to like something that is controlled by us. And so we can analyze the call that is being done. And after analyzing it, we can decide if that call is legit or not. And if it's legit, we can just revert the execution back to like the original bytes and execute the original instructions. So here is like a small like scheme of what is happening. And so basically we have like the function in this case is anti-close that is hooked, and then we jump to like a memory area that contains is just a stub, like a trampoline, to jump to the actual DLL of the antivirus. And then if the antivirus decided this is not a malware, it will jump back to the original function prologue and then to the function, the original function itself. So now let's move to the fun part, and so how to circumvent all those measures. So static analysis. One trivial way of bypassing static analysis is using encryption. And in particular, if we are interested in, for example, just hiding some parts of our malware, for example, if we have a packer and we want to hide a shortcut binary inside our packer, we must encrypt it because otherwise static analysis will catch it. We have also to take care of which kind of encryption we use because we have to be aware of entropy. because entropy is like when we encrypt stuff, entropy is very high inside the file. And so antiviruses knows that, and they might get suspicious if we have a binary that has a really high entropy. And like in this case, we showed like two pictures. This is cmd.exe, the entropy of cmd.exe, and on the right we have the entropy of a packet file that contains mimikatz inside. And as you can see, we have like this flat line that is a huge indicator of encryption. A more interesting thing to bypass static analysis is using LLVM obfuscation. LLVM is a toolchain that can be used to compile programs, and so it uses intermediate representation to generate the actual binary. So we will start, for example, from C code, and from C code we will generate this intermediate representation, which is basically bytecode, like we have in Java, for example. And then from this bytecode we can generate the binary, and doing this on this last step, we can apply some passes in between, and those passes may allow us to obfuscate the binary. In this case, we showed, we are mentioning Janso LLVM just because it's the one that we use mostly. It's a really cool project. It's an in-tree obfuscator, which means that you have to compile Janso LLVM with the whole toolchain. So you will get like the LLVM toolchain, and you will have to compile everything together. And after you compile everything together, you will have like a new version of LLVM that will be also allowed to obfuscate your binaries. Here is just like a picture of IDA Pro with the binary obfuscated with Janso LLVM, and you can see it's really ugly. So let's move to sandboxes now. So dynamic analysis. There are many ways of documented of bypassing dynamic analysis and sandboxes. Here we decided to show the offer you have to refuse, which is an interesting technique that exploits the fact that sandboxes have limited resources. This technique was documented by Sievages, and here is the paper, which contains also other techniques for bypassing dynamic analysis. And it's quite old, but most of the stuff that is inside that paper still work because basically it just exploits limitation of sandboxes. Just a brief overview of how it works. So we are showing you two flavors of this technique. So one flavor uses memory to define, exploits the fact that we cannot ask to the sandbox to allocate a large amount of memory. And the other one exploits the time and exploit the fact that the sandboxes cannot run indefinitely in time. And so if we do some useless computation for a right amount of time, we will trick the sandbox to just give up because it cannot run forever. And so it will think that everything is okay because our binary just did something that didn't have any malicious purpose. And for example, we can just do math operations. However, we have to take care of which operations we do and how we measure time, because we cannot just sleep, for example, because the sleep can just be skipped by the sandbox. So we have to do some kind of operations that are memory dependent between each other so that the sandbox cannot guess what is happening after the the computation, and it's forced to execute the whole computation. Here we show just an example. This is C code that implements those two techniques, and just as an outline to show you how you can code it. Now, behavioral analysis. So let's start from .NET. So as we said before, we have AMSI and DTW, and AMSI and DTW are in user space. Like those two tools works in user space, and they work inside our own address space. That means that we have complete control of what the provider sees, and one trivial way of doing that is just patching the memory. So we have these two functions that are ETW event write and AMSI scan buffer, respectively, and we can just retrieve them in memory and patch them so that they will always return success. And basically, the provider we won't see anything anymore because we are always saying that everything is okay. A smarter way of doing this is by using hooking, which allows us to filter what the provider sees and doesn't say. And so we can use like a hooking engine, for example, the tours, or but this will require again to patch memory because the tours using memory patching to hook. Or we can use hardware breakpoints that does not require any memory patch, and we just have to set some values inside the processor so that when the code, the processor executes some address, we will get notified from that, and the execution will pass to something that we control. System calls. System calls are used for bypass hooking. So user space hooking placed by antiviruses is needed for monitor what is happening inside the system. Eventually, every API will call a system call, which is the final interface with the operating system. So if we can speak directly with the operating system without passing through the higher level APIs that we have, we can bypass all the user space hooks because we are speaking directly with the operating system. And so we are asking the operating system to get the services that we need without passing through all the higher levels. However, this has a major issue, which is that system calls are associated with an ID. So every system call, every service in Windows has an ID, and those IDs changes between Windows releases. So there was a blog post published by Elephant Sales a couple of years ago, where he discovered that basically we can find the number of the system calls at runtime by just ordering the ZW functions inside the NTDLL, and then we assign an ID in ascending order by using the address of the function, so that we don't need to actually know the number because we can retrieve it at runtime every time. In addition, this technique allows to get the right numbers even if the system call is hooked, because other techniques to retrieve system call numbers basically search for the system call stub and then parses it, parses the gadget of the system call stub and searches for the number. But if the system call is hooked, that number won't be there, most probably, and so the technique will fail. In this case, we will always have the right value of the IDs because we are exploiting the fact that those functions are there in memory, and so we are not relying on the content of the function, but just on the place where the function is placed inside the binary. This technique has been implemented inside syswhisper2, but it has, after some time that people started using it, antiviruses started to detect it. And Clicks wrote an article about that. There are a couple of reasons why this is happening. The first reason is that the syscall instruction will be inside our main program. This means that static analysis can easily find it because the syscall instruction is never supposed to be inside the binary because system call instructions are always inside the NTDLL because that's how Windows works. So finding a syscall inside our program might be suspicious and might trigger further detection, further analysis. And another thing, which is also more interesting in my opinion, is the stack trace. So basically, when there is a normal system call inside Windows, there are a chain that you can see on the left of calls. And so the stack trace will have that we will start from some call that at some point will arrive at NTDLL, and then it will pass, switch context and will pass inside the kernel. When the kernel returns to user space, the return address must be inside NTDLL. In case of syswhisper2, this doesn't happen because since the syscall starts from our main program, the OS will return to an address that is inside our program. And so this is another indicator that we are running direct system calls. Clicks in this article wrote a solution for that, which is implemented in syswhisper3. And basically, the idea is to just create all the context for our system call as we did before, but we call the system call from the NTDLL. So we just jump inside NTDLL and we call the syscall instruction from there, so that the kernel, when we come back, the return address will be exactly inside the NTDLL. One thing that it's worth mentioning is that in the original repository, they use R15 for like storing the address of the system call, but the syscall address. But this might lead to unexpected behavior because R15 is like should be curly saved. So if our process doesn't call it, if our process the caller uses it and we overwrite it, it will lose the information and the program will crash. If we use R11 instead, we can use that because R11 is caller responsibility to save it. And so that means that the program, any function that is going to call something else will have to save R11 and take care of it because that register might be overwritten. And so we can just use R11 to store the address of the syscall instruction and then jump to that address to like use the indirect system calls. Direct system calls in C#. So this is a project I've made some time ago, and it's basically just a C# porting of sysWhisper2. It's really easy to like move it to sysWhisper3 actually, because we just have to change the stubs. But the cool part of this project is that it exploits like how the .NET framework works. It uses a tool called Sharpasm, which exploits RWX memory inside .NET processes. This works because .NET, like every other like JIT compilers, uses RWX memory regions to store the code because the code is like generated at runtime, and so they need some regions that should be writable and executable at the same time so that the code can change. Sharpasm exploits this and abuses those free chunks of RWX memory to store our assembly code. And those are the high-level steps of how this works. And what we do is we enumerate all the process address space, and then we look for areas that are marked as RWX and memcommit. Once we find those areas are like candidates for our like shellcodes. And then we will start from the bottom of the page, and we will start to search for a sequence of 0 bytes that will allow us to store our payload. We are starting from the bottom because it's less likely that the framework will overwrite our like shellcode, because the problem here is that we might have a race condition, because while we write it, the framework of course does not know that we are doing that and might use the same memory region to store other stuff. So if we start from the bottom of the page, this is less likely to happen because the pages are really huge, like are large. And so if we write small assembly stub, it's likely that like in practice, this always works. And if it doesn't work, we just throw an exception and try again. So let's move to ᴜᴜᴜ now. So ᴜᴜᴜ is like the heart, I would say, to remove user space hooks so that the AV will be, here I wrote blind, but it's not actually blind because we have kernel callbacks. So it will just see less. And there are a lot of different techniques coming out for ᴜᴜᴜ. We decided to present just 3. So SecurityCert, and we provide an implementation of it like from this guy, Slarian. Then we show Perun's part, which was like popularized by Sector 7, and we link here to the blog post. And then we're going to show you Whisper to Shout, which is a technique that we developed, me and George developed, and here is the link for our blog post with all the like low-level details of how that works. Let's start from SecurityCert. So SecurityCert is really easy. Like the concept of SecurityCert is really easy because the idea is that we are going to get the original libraries from the disk so that we are sure that they are not like hooked because the hooks are placed at runtime. So we map NTDLL or any DLL that we want to unhook from disk inside our process, and then we rewrite the text section of the process with a unhooked one, so that like we are just like overwritten everything, and the hooks won't be there anymore. However, this technique has a number of pitfalls. First of all, we will have for a period of time, and the DLL will be mapped twice in memory, and this is a huge indicator that something bad is happening inside the process. Moreover, we will call some syscalls or API to map and unmap this image in memory. And as we saw before, like EDRs can use kernel callbacks to detect that we loaded an image. And so if an EDR says that we are loading two NTDLLs, for example, in memory, this is again an indicator that something wrong is happening, because NTDLL is always present inside the process before everything else happens. So it should never happen. And finally, some AVs checks for hook integrity. So if we just override the hooks inside the NTDLL, sorry, those hooks will be placed again after 1 second, because the AV will just check it and we'll see that the hooks have been removed and we'll just replace them. So parent-fart is another technique for hooking that relies again on a clean NTDLL, but in this case, instead of reading it from disk, we read it from another process. This works because if we run the process in suspended state, the DLL won't be hooked yet, because the DLL is hooked after the AV injects his own DLL to hook. So if the process is suspended when we create it, we will just have NTDLL inside the process. So the idea is we create this process in suspended state, we read the remote memory of that process so that we can like copy that in our process, and we overwrite our the text section again of our process, and we terminate the sacrificial process. Again, here we have a couple of pitfalls. We have to create a new process, and this will trigger a kernel callback, might trigger a kernel callback. And also we have to use NTDLL with readable, writable, and executable permissions, which is really bad, because NTDLL should never be, well, actually any process should never have RWX memory unless it's like .NET or G stuff. So if we are doing like malwares, we don't like using RWX memory, because it's an indicator that we are using like floating code. So let's move to like the last technique, which is whisper to shout. This does not rely on any clean NTDLL, because the idea is that we are just we have all the information that we need to hook, and we will just work our process address, the process address space, and follow the pointers to retrieve all the information that we need, and then we will just patch the memory again to remove the hooks. So first of all, we have to like do some like to say that to allocate memory to like the stubs needs some memory allocated. To allocate this memory, we have to use virtual alloc, or like the family of virtual alloc functions, which means that the memory will be flagged as private, because that's how like the memory is flagged when we call like nt-allocate virtual memory. So we have like the first indication of where we have to search for this kind of like stubs, because we don't need to search, for example, every DLL that is inside the memory, which will be marked as a sec image, but we have just to check for all the private memory areas inside our address space. Here, now we will show, like we will work through the pointers to show you how this works. So as an example, we took aldr load DLL hooked by AVG. And so as you can see here, we have a jump to something. And this is the first hook, like the hook actually. And this jumps to a private memory area, because as you can see, there is just an address. There is not written any like name of a DLL. So this is a private memory area. And if we jump there, there is just another jump, which is basically trampoline to go to the real AVDLL. And if we check, this points to ASW hook, which is the DLL used by AVG to like hook. If we jump again to the AVG DLL, we will see that at some point it will make a call to some memory area, which is again private because it doesn't write any name there. And this memory area, if we follow the jump, will contain the actual code, like the actual instructions that were removed from the original system, the original function. So if we follow that jump, here we will see that we are landing again inside NTDLL, and that means that the circle is closed. So to summarize, we have like private memory areas that will store those stubs, and then we will have the hooking stub and the trampoline that are placed inside those memory areas. And so if we are able to retrieve all those information, we can basically just recreate the loop of like the function without having to care about the AVDLL. So here is just a summary of what we said. And so let's move to the actual idea. So we work the pointers, and at some point we will retrieve the original prolog of the function, and we can just override it. However, as we said before, some AVs will check that if the hooks are in place. And so this technique might not work always. So the workaround is that we just patch the hooking stub so that we jump directly on the original stub, and we just bypass the AVDLL so that if the antivirus will check the hook inside the original function, there will be a jump, and actually there will be a jump to the very same address that he placed it. But in the like in the stub, in the trampoline, the jump won't go to the AVDLL, but will just go to the original function prolog. Let's change topic now, and let's speak about memory allocation. So module overloading, or DLL hollow, is a way of storing the payload inside something that is backed on disk. This is done because, like, this is useful because memory that is backed on disk looks less suspicious from like an AV perspective. And in addition, we can use Microsoft signed DLLs to store our payload. And so we will have like a Microsoft signed DLL inside our process that will actually run, for example, our Cobalt Strike beacon. Those are the steps. It's not difficult to implement. Basically, we find the sacrificial DLL and we map it in memory using nt-create section, and we pass the flag secImage, which is the most important part of this technique, because passing this flag will allow us to have memory that is flagged as image inside the process. After that, we just map it again. We map the section with nt-map_view section, and we will have memory allocated. After that, we can just overwrite the piece of like memory that we need with our payload and just jump to it and execute it. Here we show like the difference between memory. This is Process Hacker, and we are showing the memory, the difference between module overloading and nt-allocate virtual memory. As you can see, like this is actually Mimikatz, if I'm not wrong. So as you can see, Mimikatz is running inside aadtb.dll, and it's less suspicious than seeing something marked as private, where that contains like that is not backed by disk. So it might be something that has been like injected at runtime. And here, just to show you the difference between like this is like a real ntdll and a payload that uses module overloading to store the payload. Module overloading has some pitfalls that we have to take care of. So first of all, the sacrificial DLL will not be added to the PEB list of loaded modules. This is not done because normally this is not it is something that is taken care of by load library. But since we are not using load library to do that, we won't find those like those modules inside the PEB. And this may be an indicator that we are using this technique. To avoid this, we have to create a structure inside the PEB and add it to the list. The structure is called LDR data table entry, and we have to fill it with all the information that this structure needed. It's a bit tricky to do. One easy way to do that is just to copy one of the LDR data table entry that are already in memory, for example, from kernel 32. Or you can just reverse it, so get like a debugger and check all the values that are there, and by trial and error understand which are the values that are correct and the values that make you crash, like the process. Another thing that we have to take care is section permissions, because like the PE headers of the sacrificial DLL will contain the permissions that is expected to have like at runtime. However, if we overwrite it and we change the memory protection to fit our payload, we might have like a mismatch between those two things. And this is another indicator that this is like something wrong is happening in the process. For shellcode, this is really easy to overcome, like to avoid, because we have just to get the sacrificial DLL, which has a text section large enough to store the shellcode, and then we write that there the shellcode. So the text section is by definition readable and executable, and the P headers will be matching the in-memory layout. For PE, this is a bit more difficult because we have to be consistent for every section. Finally, there is an IOC that there is no way to address, which is that the content of the sacrificial DLL in RAM and on disk will be different, of course, because we have written it. However, checking this is really expensive. Like, for example, Moneta tool is one of the techniques that uses to detect malwares is checking if the DLL matches the content on disk. But like in real cases, EDRs cannot do that for every process, for every library, for every computer in memory, because this is really expensive, because it requires to actually touch the disk, and this is way slower than using like speaking with RAM, like talking with RAM. Module overloading can also be done remote. The main issue here is that we have control flow guard, which is an exploit protection mechanism like utilized by Microsoft to mitigate rob chain attacks. This is an issue for us because when we are jumping inside a real, like inside the library that we have mapped, that library won't be added to the list of allowed addresses, because a control flow guard maintains a list of, which is actually a bitmap, but we can think it as like a table where we have all the allowed addresses that we can jump on. So in this case, we won't have that because the binary wasn't supposed to contain that library and to jump to that point at like when we compiled it, and so the program will crash. Also here I have the blog post, the proof of concept, because this is like a huge topic and we don't have time here, unfortunately, to go deep into details of this. But let's go directly into the bypass. So we have two ways of bypassing it, at least. One is, again, memory patching. So the function that is doing the bitmap check is called rdrp dispatch user call target, as is inside the NTDLL. And we can change some bytes in memory to make the program think that the lookup of the bitmap has always succeeded. And so basically, when the check will arrive there, it will always think that it's okay, and the address will be allowed, and we will execute our code. A way easier way of doing that is using setthread context. So if we create a thread in suspended state and we change the thread context so that the RIP register points to our shellcode, we will actually bypass CFG, because the checks done by control flow guard are done before we execute, when we create the thread, before we execute our code. So if we force the thread to execute directly inside if we force the thread to execute directly our code by overriding RIP, we will just bypass that function, because that function will never be executed. Here I show you the code, which, as you can see, is like 4 lines of code, so it's super easy to do and doesn't require any memory patching. Now it's worth mentioning also like PE loaders, because if you are creating a packer, or if you are creating, for example, an implant or like a stage 0 implant, you will need probably to run some PEs from memory, because you don't want to touch the disk. And so to load PEs in memory, we have to take care of some stuff, because PEs contains an header which like describes all the information that will be used by the loader to like create the context of the process. And we have to recreate what the Windows loader does for our PE, and we have to follow the following like steps. After allocating in memory, we copy the sections, and then we do some operations that will depend on where the payload, where the PE has been like allocated in memory, so that we will apply the relocations, and then also we have to like resolve the imports, because like libraries that are dynamically loaded are needed before we actually execute our entry point. Then, after we have done we have created all the context, like the right context for the PE, we just jump to the entry point and we will execute it. Here we added the link of Stephen Fewer PE loader, which is probably the most famous reflective DLL loader. This implements all the steps that I mentioned now. Like it's a good start for if you want to run, if you want to code your own PE loader. For .NET, it's actually even easier, because we have to load the CLR inside our process. This like doing that has some advantages. For example, because we can patch ETW and DAMC before we actually load something malicious, and so ETW and DAMC won't see anything at all. Plus, this is sometimes needed. For example, if you're using Cobalt Strike and we want to use it, which runs in an unmanaged process, and we want to execute something like a .NET assembly, like Rubius, we need like a way of loading at runtime the CLR to execute that in our process. And so loading the CLR and executing, then loading the memory of the .NET assembly and executing the main function will do the job for us. Now I have prepared a small demo. I have a video here. So in this video, I prepared also a proof of concept, and I will publish it probably this night. So we created a packer for shellcode, and it will run a Cobalt Strike shellcode, and it implements also Hanukkah using ShellCode, using the same repository that we mentioned in the slides. And then it will use the offer you have to refuse, the computational one, to tricks and boxes, title bypass and boxes. And then it will decrypt the payload and execute it. Everything will, I forgot to say that it's using DLL holo to do that, so like module overloading to allocate memory. And yeah, that's it. Let me run the video. So this is AVG. Also in the video, I'm showing you not about .exe. I decided to use AVG because it hooks stuff. So I can show you also that there are actually hooks there. And after we run the payload, there won't be any hook there. So here is not about .exe. Here we are going to search for LDR load DLL as the slides. And so we will see here that there is a jump to something, and yeah, if we follow the jump, there is exactly what we showed in the slides. And now we're going to run the payload. So I created a DLL that can be run with MSI exec just to be a bit more stealth and not using just run DLL. So I'm going to run this DLL that is that contains a Cobalt Strike beacon. And in a couple of seconds, you will see that now it's running the offer we have to refuse. So we are trying to trick the sandbox. And now we have to wait for around 13 seconds because, like, experimentally, we found that 13 seconds is a good value for sandboxes, because after 13 seconds, 14 at most, they will give up. And as you can see, I've got the beacon, and AVG didn't complain at all. And in the meantime that we wait the beacon to beacon back to show you that it's working, I'm showing you like LDR load DLL that in this case won't be hooked because we have applied the hooks. We have removed the hooks, like we have applied Hanukkah. And yeah, the beacon is going to like beacon back in 20 seconds. And since we have other like 5 minutes, I'm going to show you like quickly how the code works. Then I will leave a couple of minutes for questions. So here, as you can see, I've got the result. So it's working, and AVG didn't complain at all. The code here. So where So this section remap.h is taken from the repository of ᴤᴜᴜ, and let's open DLL is .c is taken from the repository of SecForce, is the proof of concept that I mentioned in the slides. It's exactly like copy-paste from the SecForce repository of DLL and added here. So here is the code. So the logic is we do some computation, so the offer we have to refuse. Then we run section remap is the function used for learning ᴤᴜᴜ, basically. Then we decrypt and we run inject here. This function is the function that allows us to inject the shellcode using DLL and creating running everything. It will allocate memory and then create a thread, and then basically that's it, because the payload will run and we will wait for the sandbox to the anti-sandbox code, and then we will get our shell. Yeah, the talk is over. Thank you for the attention. If you have any questions. Okay, cool. Thank you very much.
Ed eccoci qui dopo il primo speech, devo dire molto interessante. Claudio, questa però è materia tua, sono cose che mastichi tu. Grazie Fabio, se volessi accomodarti con noi, non so se... Ciao. Durante questo intermezzo, come dire, sì,
è materia che mastico io e che fa sempre comodo rinfrescare e scoprire tecniche nuove, perché oggi abbiamo, lo scopo di un analista vede quotidianamente stare a detectare tutto quello che durante questo talk abbiamo visto come non farsi scoprire.
Esatto, giustamente abbiamo visto il lato red, in realtà sta già per iniziare il secondo talk, non ho il tempo di scambiare due chiacchiere, però ecco, abbiamo visto alcune tecniche di offuscamento, no? Di evasion, analisi statica, analisi dinamica, magari se c'è qualche appunto magari ce lo prendiamo anche con la nostra chat, dopo cerchiamo di discuterne un pochino.
Molto volentieri. Io darei parola al prossimo talk che sta per iniziare praticamente.
Esatto, e parliamo di API crypts, vedo. Ok, esatto. Vediamo un po' che cosa ci dice, e ci rivediamo ovviamente qui dopo lo speech.
Regulation tech related and is called Remo. I'm also an independent security researcher. My research interests are mainly, obviously, API for IoT devices and web application security. You can find me on Space Current site as ᴑᴜᴜ and on Mastodon as ᴑᴜᴜ at the InfoSec Exchange, and this is my personal website, ᴑᴜᴜ.com. Let's start with what is an API. I really like MuleSoft's definition of what an API is. It's the acronym for Application Programming Interface, which means that it's a software intermediate that allows two applications to talk to each other. Usually, people shouldn't see APIs, but yeah, we are going to see a lot of APIs in here today. My definition is that an API is an easy way to interact with a DB layer. You write the API once and you use it everywhere. You use it in multiple clients that you can see, mobile devices, enterprise application, TVs, games, pretty much everything that you see and seems complex has an API. There's another really interesting API to API connection that was used a lot in Twitter. Unfortunately, in the past week, they have decided to disable API to API connections, so this is not happening anymore. In that, I had a nice example for Twitter API to API connection, but it's not here anymore. Well, APIs are really easy to build, but they are really difficult to build them securely. The type of APIs that we are going to see in here is first the REST and foremost GraphQL, which is the new kid on the block. It's Facebook query language API. SOAP, which is a really old implementation that XML was actively enforcing, and I'm really happy that it is dying, and the non-standard APIs that are being used by a lot of devices. First of all, it's the REST API, which is CRUD. By CRUD, we mean the create, read, update, delete. You're going to see on the right side that the create is post, the read is get, the update is put, and delete is delete. Those are the verbs. They're really easy to identify. It's the most common APIs that we see right now. The recent study said it's about 65 to 70% of the APIs. It's easily predictable because it is uses entities. So if you have seen enough APIs, you can usually guess what they're doing, what are the entities, how you're going to create something, or how you're going to delete something. Then it's GraphQL, which is again easy to identify, but really trickier to read. It needs some reading on the specifics so that you can get used to it. But after that, and after understanding the custom query language, it's super easy to enumerate. It has introspection, which some companies have them enabled. And if a GraphQL API has introspection available, it's really easy for you to do a lot of strange and bad stuff. It returns JSON, but not the nice JSON that REST APIs has. It's something totally different. Next is SOAP API. I'm not going to use a picture for it because I just hate it. It's really old school. It returns XML. It has an envelope format, which means it has a header and then a body and then another header. Microsoft used to use it by a lot. It had WSDL and SOAP, but thankfully it's moving away from it and starting to using RESTs. Custom APIs can return everything or anything or all of it. It's being used either via WebSockets or random HTML requests. It's being used extensively on proprietary devices, medical devices, and other IoTs. That thing that says JSON in XML in JSON is unfortunately true. You're going to see a lot of XML in a lot of JSON in a lot of other places. And when you try to understand what it's saying, you just have a terrible headache. Documentation on APIs are either freely available, so a well-documented API can give you a better understanding of the structure of the API and how you can interact with it, or how you can make it do things that it shouldn't, or you can find the forgotten documentation, which is usually a gem that you are going to use on your attack vector. Now, where APIs are used. They're used in IoT devices, they're using in web application, they're using mobile application, they're used pretty much everywhere. Industrial IoT, vehicles, pacemakers, you name it. If it is something that has an internet application, an internet connection, it probably is using some kind of API. What we can do with APIs and attacking APIs. Usually when I started like 7 years ago, everyone was saying, yeah, it's just APIs, you cannot do a lot of things. I have proven that you can gain full functionality of IoT devices. You can make them do unintended things. You can make them burn, which is an interesting thing that an IoT device can do. You can punch through firewalls. You can pivot to internal networks, and you can reflash them and potentially make them a break. You can also do SMS attacks. If there is an SMS vector, you can make them a botnet. You can do ransomware attacks as you are inside a potentially unreachable network, and you have no need for shutdown because we are talking about cloud, so you just interact with all the devices. There is a special place for what the Chinese clouds name API sharing. So a lot of the Chinese clouds are using API sharing. So they have a unified API for a lot of their IoT devices. And when you hack a bathtub, you end up with root in medical devices. I have seen that. We have I have published that more than once. You are owning a device and you are ending up with a totally different class of devices. A special category that I really like is industrial IoT, because historically they're isolated. I see that we have an IoT talk later. They're isolated, they have a long lifespan, so there are IoT devices in there that are older than me, and I'm 40 now. They're rarely updated, they're safety critical with a high uptime, their protocols are usually unencrypted, and making it smart means that usually they have an IP to RS-232 M2M, which you end up on a device that just gets RS-232 commands from internet, and that rarely goes well. Yeah, Mikko Hipponen said, if it is mad, it is vulnerable, and we're going to see that this is the case for a lot of devices. So what's the plan for the talk? We're going to see the severity, we're going to see the exploitability, and we're going to see how we own most of the devices. Unfortunately, I'm going to be bad in here. I have deleted a couple of exploits because they're still 0-day, and I would prefer not to end up in jail. So what are the vulnerabilities of APIs that we're going to see? Number one on OWASP API top 10 is IDORs or BOLAs, insecure direct object references. Number 3 is information disclosure, and that's usually when the API returns everything when you shouldn't. So think about Amazon. If I say, can you give me my phone number? And Amazon API gives me everything that I have ordered in the last 20 years, and the client is just filtering it. It's probably not a good idea and not a good design. The other thing is authorization issues, which we're going to see that a lot of APIs, they think that authentication means authorization. Those are two totally different things. It's injections, like we're back in the 90s, we're going to see that a lot of APIs also have SQL injection, XSS, and business logic flows, which is my favorite one. It's making APIs do things that they shouldn't. I have to have a legal disclaimer in here. CMA in crime alert. API research is really tricky. Never, ever, ever interact with a device you don't own. If you mistakenly do it, please notify the vendor immediately. Getting platform admin means that you're breaking CMA. CMA is the law in the UK, which means Computer Misuse Act. Anything that is in red in the following slides is breaking the CMA. So I have a good lawyer. If you don't have, don't do it. First is classic IDOR, as we said. You have to learn that authorization is not equal to authentication, or API issues will come after you. So it's the easiest of all of them to find. You just see the ID, you press +1, -1. If you see data in there that you shouldn't see, this is a typical IDOR. Typical symptoms of missing authorization and just having authentication. GUID is not a solution. GUID could be predictable. You shouldn't depend on GUID. You should have proper authentication, authorization. It could lead into leaking. It could lead into leaking a full data set. First example is the Viper Smart Alarm. You can see on the highlighted parts that, unfortunately, it's on top. You can see that you could use a post request to update any user. You could just change the password or the user email and end up with remote control of any vehicle, alarm functions, identify vehicle, and geolocate it in real time. So you could find a Ferrari in here and unlock it and steal it. You could stop the vehicle. You can panic alarm and pop the trunk. Second is one of my favorite IDORs. It's Project EV. That's an EV charger. You're going to see that the only thing that it had in there is a charge ID. There's not even authentication. So you could just randomly start unlocking, stopping. lock and lock, remote firmware update, backdoor, pivoted to the internal network of the company. You could break it. You could take platform admin in there just from that single request, unfortunately, or fortunately, how you say it. Again, learned on authorization is not equal to authentication, or you're going to have a really big problem in here. Injections. We want to state that the next 3 slides are all breaking the CMA, so don't go and do SQL map into random websites. The good thing is that there's an automated ways of finding them. It's called SQL map, it's called burp. Don't go and do unauthorized scans in random websites. They are nowadays really rare because we have ways of defending around them, and it could lead to RCA. This was on my talk of Bsides London. It's the Truth Spy. They had an SQL injection, and I'm not going to say what the SQL injection is because it's still there, and it's all red. You could remote control all the monitor devices. We're talking about 500,000 of devices that were actively monitored. You could link the full data set and the images from there. You could RC on all the servers, and if you are a good person, you could possibly identify a crime syndicate and go to the FBI that will be after them, I guess, or after me, I'm gonna say. How you can defend against injection? Use a modern framework. For the love of God, don't use just PHP and ASP. Sanitize your inputs. Keep the principle of least privileges. Don't run your databases as root or SA. Do not share database or credential between your projects because you will end up being owned massively. The third one is the lazy REST implementation. You need to check response and request. It's a typical symptom of using an ORM lazily. So the ORM is mapping the full object to the database. You always need to check for allowed parameters on user input, and you could lead into platform admin. A really nice charger, EV box. You can see that I could patch my own user, so they had authentication, but I could add any role that I wanted. So the role that I wanted was account owner that I already had, admin, and the tenant admin that the whole system, when I added a role 1, it said, do you mean tenant admin? So I said, yeah, well, heck not, I mean tenant admin. Why wouldn't I want tenant admin? It ended up with all admin functionality, platform admin, server admin, RCE, because tenant admin means I could run commands anywhere on the tenant, PII leakage, and total compromise of everything. How you can defend about it is check response and request. I think I have read that before, right? You need to check what you're doing. You need to whitelist, allow list the parameters. You shouldn't accept anything that is not expected, and don't accept just lazy ORM implementations. Another lazy REST implementation is one from the Kids Watch that was with Troy Hunt's daughter. You can see that there is a family identifier in here that's proper queries. So if you change the family identifier to something else, you could see in here that you could actively see where it was. You could change where your kid was, and you could end up, I don't know if we have listened in here. Do we have sound? This is Troy Hunt's daughter. She was there in Australia, and I was just calling her from Greece, creeping her out because I have a really creepy accent. And I also, she's talking to me here, and I'm saying in creepy accent like I'm Vangelis from Greece, from the other part of the world, because, yeah. And during that call, I also faked her location to be with me in Greece. That didn't ended up really good with Troy. We had all admin functionality, also platform admin. We took total compromise of everything and could change all of the locations of the devices. If possible, avoid using functions that automatically bind the client's input into code variables or internal objects. Whitelist everything. Don't trust any of your inputs. Explicitly define and enforce schemas. Don't try to use anything automatically generated from a framework if you don't know exactly what you're doing. This is my favorite one. It's user group juggling. I really like changing user groups. There's multiple potential ways of user group juggling. When I see a web application that says add the user to your group, I really like it because I want to add a user to another group. Sometimes create is not vulnerable, but edit is. So you just add it on your group and then try to change it to another group and then to an admin group and then being a total admin. It could lead to platform admin or accounts takeover. The first one example is ᴤᴜᴜ. You can see in here that I was able to just change the group ID and have access to any ᴤᴜᴜ in there, which is routers, firewalls. I could change VPN. I could take the security reports. I could take the traffic analysis. I could literally get SSH access into the internal network and do a ransomware attack. Don't do that. Never do that. Web application firewalls. You practically had admin on that company's software as a service provider from ᴤᴜᴜ. Another one is I really like Mimosa, not the drink, the antennas. Again, you could just go in there, post to a user ID with a different ID, so you can see that's 1, 2, 3, 4, and the ID is 1. And you could link everything. You can access, again, the internal networks. You had SSH access. You could have full organization access. And again, the same thing, ransomware, don't do that. You have a lot of potential without using shutdown or any kind of, I don't know, red teaming, mumbo jumbo that I don't really understand. Totally respect, but I don't understand because I'm dumb and simple. You should never be lazy and always check for correct authorization. Again, don't do it, especially on user access functions. See that the user that you want to add has access to where you want to add. Second level IDOR, it's one of those IDORs that the first parameter is correctly authorized and you're like, oh, they're one of the goods, they know authorization. And then you have a second level and that doesn't have authorization. So the fact that there is a check on the first level does not mean it's everywhere. You should always check as an attacker all the parameters, check every combination possible. It could lead into account takeover. Another EV charger, wallbox. It had the access configs on the top, had a proper authorization check, but the chargers didn't have any authorization check. So I could take all the chargers and put them on my access config and have access to all the chargers and total control over all the chargers. I could lock and unlock. I could take the PII of every user. I couldn't, unfortunately, firmware update them, but I consider it a win still. The last one is REST verb juggling. So read the REST principles, try to change if something is getting, try to post it, try to put it, try to guess what function would not be implemented and see if you can override that. It could lead into platform admin and account takeovers. Unfortunately, I cannot talk about the API that had that vulnerability because they still haven't fixed it for 7 months. So no 0 days for you, unfortunately. Again, never use the full control URL mapping unless you know you will need everything. Disable the functions that is not needed. If you don't need to update the user, disable the patch, disable the delete, and always check for proper authorization. Hide the endpoints. So you should read the JavaScript as the attacker or the Android source and see for endpoints you don't see in your interactions. What I usually do, I have an AI, I have a Python script, which is not AI, but I'm going to say AI for it, is take the burp request for after using the application, then parse the Android source code, extract the functions, and see what have I missed and what I haven't seen. More often than not, I can see hidden endpoints that have functionality that is either disabled or admin related. You should use automated tools. You should try to think where corners were cut from the developers. It could lead to a lot of nasty stuff. One of the things is a car alarm that I have taken care of. It was called Pandora. They said they weren't hackable, so yeah, they weren't. Long story short, they had a hidden endpoint that when a newcomer, a new worker was onboarded, they were said, create the user, and then we're going to upgrade you. They had that JavaScript in there. So yeah, I just upgraded my own user because why the heck not? So I could geolocate any vehicle, I could unlock it, I could stop it. I could listen to someone from the internal microphone. I don't know why the functionality was there, but I could have it. And I could potentially profit. That should also be in red because I cannot see of a non-criminal way to profit of that. The other one is a really strange, what was the name of the SE tracker, of a tracker device for your kids. There was a JavaScript file that was named backup.js. It was referenced by a map. I ended up with all the source code because that backup.js was zipping everything into a zip file. So I downloaded and read the code. They had static keys, SSH password, database configuration, everything, full RC on 40 servers and all the devices, info. We're talking about 1 million of devices of children's watches. What you could do is geolocate any device, use it to send SMS and phone. I usually say that if I have enough phones, I can win Eurovision. I don't know why it makes sense, but people like it. You can listen to someone from the microphone, and those someones are usually minors, so this is also a big crime. Another hide there endpoint is on an EV charger that they had the GraphQL introspection available, so you can see everything for everything, you can interact with everything. We can stop a car charger, you can charge for free, go there and charge someone else as you could unlock the device. PAI was obvious. I could see all the users' data and where they were and where they have charged last time. I couldn't see any CC, thank God for that, but anything else could be queried. For the hidden endpoints, keep in mind that people will look at your devices, will decompile your application, they will have to be brutal with you. You always have to verify that the hidden endpoints has proper authentication and test for broken workflows for both automated and manual. So whatever you do, you have to do it as another user. You have to change your cookies. You have to then check on admin functions as the user, on admin functions as a non-admin user, etc., etc., etc. As general recommendations, it is critical to authorize all your requests. Authentication is nothing if you don't check that the request is correctly authorized. Rarely, only once I have seen something that is nothing is authorized. It's usually 1, 2, or 3 requests that have been forgotten, but they're often more than enough to get everything. Never, ever, ever trust user input and check that every request is authorized once and for all. Any questions? Thank you.
Estremamente interessante. Nel frattempo, ecco, viene chiamato il break di 5 minuti. Ecco anche Fabio che torna in postazione. E volevo in realtà spendere 2 parole specialmente su quest'ultimo speech, perché sì, qualcosina in più, come dire, se prima era materia solo e prettamente tua, adesso riesco magari a condividere qualcosina in più anch'io. Mi è ammetto che mi è piaciuto molto quello che ha detto il nostro relatore parlando di quando ha detto di tenere a mente, insomma, che qualcuno sarà sempre lì pronto per decompilare la tua applicazione e per vedere come funziona. Cioè è proprio il concetto da cui nasce come dire, il termine hack, no?
Assolutamente.
Sono nati un po' per questo, in un certo senso, capire il funzionamento delle cose. Ecco, Fabio, nel frattempo, appunto, qualcuno diceva non riesce a stare seduto. No, non riesce a stare seduto.
No,
se a qualcuno dovesse interessare. E quindi dicevo, è proprio il motivo per cui fondamentalmente è nato ai tempi questo movimento, vogliamo definirlo così, no?
Assolutamente sì, guarda, c'era un mio vecchio docente che diceva sempre: ricorda, mentre tu stai dormendo nel mondo c'è qualcuno che lavora all'epoca per fregarti il lavoro, però in effetti
non mi aspetto niente
sempre
di meno, no? È sempre la solita corsa del gatto col topo, per cui laddove qualcuno cerca di costruire qualcosa di buono ci sarà qualcun altro pronto. Nel nostro caso, perché comunque parliamo sempre di hacking etico, a testarlo perché sia più sicuro.
Assolutamente.
Ma
sì.
Sappiamo bene che insomma non è così per tutti, e quindi, come dire, c'è qualcuno che prova a rompere
gli schemi.
I programmi, gli schemi, esatto, non altro.
E lì poi dovrebbe intervenire il lato blu della forza, però vabbè.
Però insomma sappiamo più o meno come funziona lo schema, ecco, però.
No, comunque veramente interessanti questi entrambi i talk, devo dire. Siamo partiti proprio
col botto. Siamo partiti col botto, perché ripeto, vedere, adesso parlo in particolare del secondo speech, questo sulle API. Comunque abbiamo visto una raccolta di vulnerabilità che rientrano quasi tutte nella top 10 OWASP.
Esatto.
Quindi già di per sé un concetto così semplice come un API, che non è altro che, come dire, un passante, no? Una sorta di passante, una sorta di carrellino che trasporta i dati da un punto all'altro. È una cosa così semplice, così quasi banale, volendo semplificare il concetto, possa portare comunque a danni non indifferenti, soprattutto dal punto di vista delle disclosure, perché al di là di alcuni casi di RCE che abbiamo visto, cioè, insomma, che il nostro speaker ci ha mostrato, la cosa fondamentale è che abbiamo una disclosure di informazioni pazzesca, cioè
esatto.
Vengono restituiti dati su dati. Intanto la decompilazione esiste dalla notte dei tempi, chi di noi non la fa? Beh, ripeto, ci sarà sempre qualcuno pronto a darci del filo da torcere, no? È anche questo il bello, cercare di migliorarsi
per tentare di dare più fastidio possibile a chi dall'altro lato tenta di non essere così tanto etico, come stavamo dicendo.
Esatto, anche poco professionale in un certo senso,
esatto.
Nel senso, io sono pagato per fare un lavoro, dovrei farlo secondo tutti i crismi, no? Nel momento in cui questo non avviene, dall'altra parte è anche bello avere qualcuno che viene lì e
ti dà
e ti punzecchia, come dire.
DOS dice offuscare sempre e comunque.
Allora, anche l'offuscamento, Claudio, tu ti relazioni più magari con qualcosa di offuscato, perché chiaramente immagino che la prima basilare tecnica per cercare l'evasion e quindi di non essere come dire, intercettati è chiaro. Ma guarda,
che è causato
cosa?
dai come dire, giovincelli di turno,
guarda,
che
vogliamo definirli script kiddies alla vecchia maniera per categorizzarli
così, esatto.
No, sai, appunto il discorso è proprio quello, è che al di là dello script kiddie, quello che vedo nel passo successivo è semplicemente qualcuno che va un pochino oltre,
esatto,
e trova il tool su GitHub piuttosto che qualunque altra repository
e che tenta.
Però posso dirti per esperienza, diciamo indiretta, diciamo nel corso dei miei studi, specialmente per quanto riguarda la parte mobile, perché chiaramente il codice è una proprietà intellettuale come tante altre cose, capisco la voglia di renderlo quanto più sicuro possibile, capisco la voglia di renderlo quanto meno manipolabile possibile. Cioè, se qualcuno dovesse fare il reverse e quindi quello che dicevamo, non smontare il mio programma, mi aspetto di rendergli la vita difficile. Non posso rendergliela impossibile, però, perché è soltanto una questione di tempo, no? Una questione di pazienza.
Sì. Quando ti pigliano di mira, prima o poi, vabbè, qui potremmo cominciare, come dire, avviare noi quello che è un talk che finirebbe domattina parlando di tutto quello che i mostri sacri da Mitnick in poi ci hanno trasferito con i punti vulnerabili.
Certo.
Però insomma, alla fine il discorso è come dici tu, riuscire a dare quanto più fastidio possibile dall'altro lato. Questo è un discorso che quotidianamente applico con i team con cui lavoro, e devo dire che diventa sempre più interessante e divertente. Riagganciandomi al commento di DOS di poco fa, offuscare sempre, sì, però c'è sempre il però, secondo me. Di attacchi interessanti offuscati te ne vedi uno su...
Ma sai cosa penso, Claudio? Che finché l'attacco non offuscato passa, non vedo l'esigenza,
certo, non vedo l'esigenza di andare...
Esatto, complicando la vita.
Quello sì. Però guarda, tanto per, come dire, saltare da un argomento all'altro, restando comunque nel filo conduttore, leggevo giusto stamattina un post su LinkedIn che diceva che i ricavi dei ransomware nel 2022 stanno cominciando a scendere. Quindi, giusto per agganciarmi al se passa l'attacco non offuscato, perché mi devo complicare la vita, evidentemente durante quest'anno una consapevolezza di quello che è l'argomento sicurezza informatica e quant'altro sta cominciando a entrare all'interno delle aziende, anche quelle
fortunatamente,
per fortuna, assolutamente sì, perché abbiamo fatto un 2021 disastroso, per non tirare fuori i cliché dal lockdown, non tiriamo fuori i cliché, però questo è quello che sta succedendo. Quindi io mi aspetto, o perlomeno da un lato non vorrei, perché faccio questo di mestiere, la mia speranza è no, però mi aspetto di vedere molte più cose interessanti e divertenti, tipo degli attacchi offuscati o qualcosa del genere, da qui a breve.
Però sai cosa? Ecco, proprio qui ti volevo portare, nel senso, fin tanto che passa, io non ho l'esigenza di offuscare, perché il mio attacco passa, non viene detettato, chi se ne frega, cioè, sto facendo uno sforzo inutile e mi sto bruciando una carta per un attacco successivo.
Assolutamente
perché se oggi passa offuscato, domani non, oggi passa deoffuscato, domani non passa più, lo offusco, passa di nuovo.
Esatto.
Ed è, come dire, un po' un circolo vizioso, no? Torniamo sempre al discorso del gatto col topo. L'abbiamo visto anche quest'anno, durante quest'anno, con il leak di BitLocker 3.0.
Esatto.
BitLocker 3.0 è, tra virgolette, bruciato, nel senso, è vero, c'è stato il leak, quindi tantissimi avranno scaricato la repository con BitLocker pronto da utilizzare, e tantissimi probabilmente lo stanno utilizzando, facendo anche un po' di pubblicità, no? Nel senso, nel bene o nel male, purché se ne parli. Però d'altro canto, persone come te, del lato blu della forza, come ti sei definito e come la definizione che mi piace rubarti, hanno avuto accesso alle stesse informazioni, che significa poter smontare il programma di nuovo e di conseguenza andare a porre delle contromisure.
Esatto.
Aspettate che intanto l'automod fa cose e censura messaggi.
Stavo rileggendo i messaggi di DOS.
Sì, io intanto volevo approfittare per ringraziare tutti i nuovi follower, tutti i follow che sono arrivati durante la conferenza. E ripeto, sono estremamente contento di essere qui oggi, Claudio. È davvero una bella esperienza, davvero emozionante essere anche da questo lato, no? Tante volte vediamo, partecipiamo a eventi dove c'è...
Ovviamente siamo dall'altro lato o perlomeno siamo tra le due telecamere, tra chi fa
nell'audience, che va benissimo così, audience. Come dire, mi sento molto più tranquillo a mio agio nell'audience, però oggi mi tocca, oggi ci tocca l'altro lato, anzi mi fa piacere avere comunque una figura professionale e più capace di me al mio fianco.
No, è veramente bello, e poi soprattutto non si riesce a vedere l'audience, ma poco fa ho visto un paio di personaggi di varie community romane.
Sì, assolutamente.
Ho visto la presenza dei ragazzi di Sabersayan.
Sì, ho visto Giovanni, ho incrociato Giovanni che si accomodava, insomma.
Devo dire che
ci sono i ragazzi di Cyber Actors che anzi, hanno avuto anche, sono stati carinissimi, sono venuti qui, si sono presentati,
salutati, quindi salutiamo a nostra volta pubblicamente. Devo dire che, come dicevamo poco fa in apertura, questo è uno di quei eventi che secondo me chi lavora in questo settore o in un modo o nell'altro deve frequentare.
Sì,
deve
sono
frequentare per
d'accordo.
tante cose. Solitamente per scherzo con i colleghi, come dire, dipingiamo, e qui ti prego non te la prendere perché so che tu sei dal lato rosso della forza, dipingiamo il blue
Mi
team.
piace essere ovunque, in realtà, dove posso metto mani,
Noi dipingiamo il blue team come l'estremo della socialità, i pentester li vediamo solitamente lì con le cuffie,
col cappuccio, no? Quella classico proprio
e invece devo dire che la presenza di Red qui è altissima, molti più che
c'è da dire che
analisti.
C'è da dire che i talk effettivamente che abbiamo visto fino adesso
sono
non danno vere e proprie soluzioni lato blu, nel senso
infatti,
ti instradano,
esatto.
perché ti dicono guarda può succedere questo e questo, però vedi bene che non c'è, esatto,
ai pentester.
Esatto.
Dico, tra le tante cose che dico sempre, dici ma quante ne dici? Parecchie. C'è anche che secondo me un buon analista deve sapere anche attaccare, perché se non sai attaccare,
certo,
quindi siamo sempre lì, ritorniamo alle solite
in realtà
basi.
questa divisione è un po' troppo netta anche secondo me, insomma.
E quindi qua diciamo che ci rientriamo perfettamente. Eventi che dovrebbero vedere molta più platea. È vero che siamo tantissimi oggi,
tanti. Allora,
perché la sala è
sai cosa, Claudio? Io sono sempre del parere che comunque siamo una realtà di nicchia.
Assolutamente.
Siamo una realtà di nicchia, siamo molto distribuiti a livello proprio globale. Ovviamente la community italiana è più o meno grande e mi rendo conto che spesso e volentieri riunirsi in un unico luogo, come può essere Roma, come può essere qualunque altra città, insomma, passiamo da Bsides appunto che oggi ci ospita a Romac, piuttosto che a Timbo, piuttosto che il Molecon, insomma ce ne sono diversi in tutta Italia e spesso e volentieri magari si preferisce muoversi, orientarsi verso la città più vicina, però sono d'accordo con te nel dire assolutamente che vale la pena frequentare in realtà tutti, se possibile.
Sì.
Lasciamelo dire, sono tutti interessantissimi, oltretutto gli speech non sono ridondanti, nel senso non sono mai gli stessi speaker che c'è un'attentissima selezione degli speech da portare poi in conferenza
e tutti di altissimo livello, veramente. Complimenti a Bsides per l'evento, per l'organizzazione non soltanto dell'evento stesso ma proprio degli speech, la cura nei confronti dei relatori, gli argomenti, veramente complimenti. Sto vedendo che
sì, ci stiamo riaccomodando, infatti stavo per interromperti perché a breve interverrà, vediamo un attimino, perché abbiamo ovviamente scusa non mi viene il termine, la scaletta. Abbiamo Xavier Mertens che ci parlerà delle sue scoperte, diciamo delle sue indagini per quanto riguarda l'utilizzo di Python in ambiente Windows, quindi come è possibile scrivere comunque un codice malevolo in Python che sia eseguito da Windows. Non che fosse impossibile, nel senso ci sono delle condizioni, lo sapevamo,
esatto, che dovevano essere rispettate, altrimenti
però si riteneva insomma che fosse un po' dedicato, più che altro dedicato, ecco, più votato alla parte Unix, ma a quanto pare Xavier ci dimostrerà che non è così. Quindi a minuti riprenderanno gli speech, vedo già sia lo speaker che il nostro caro Vanish pronto a richiamare tutti all'ordine. E vi lascerei in compagnia della sala qualche minuto in attesa di ricominciare, poi appunto con la conferenza. Noi ci vediamo più tardi, anche perché non sono previsti altri interventi per la mattinata, quindi magari finiamo le ultime considerazioni e ci spostiamo in sala al pranzo anche noi. D'accordo? A più tardi.
Ciao ragazzi.
Welcome back. Last talk before the lunch break. So please, I require your attention for the last 50 minutes, 1 hour, something like that. Yeah, approximately. It depends on the question. And so what I will try to explain this morning is that Python, of course, I presume that a lot of you know Python. Maybe you write Python script. And you know that Python, of course, is mainly used on Linux systems, Mac OS systems, and so on, but also on Windows systems. And if it's used on Windows system for multiple reasons, yeah, there is an issue. Okay. Hello, camera. Okay. If it's used mainly on Windows system for good reasons, for example, one of my best friends, Didier Stevens, writes a lot of interesting tools. Probably you know OLE, DBA, basic for dump, stuff like this. OLE dump, sorry, not OLE DBA. Didier develops mainly on Windows systems. So Python is used for good reasons. But what I will show you this morning is that malware developers, so the bad guys, they also try to use Python for very good reasons on the Windows ecosystem. So my goal today is I would like to be something, this presentation is something like an eye opener. So I would like that after the presentation, you will realize and you will always keep in mind, especially if you are doing investigations, malware analysis and so on, you will always keep in mind that Python can be used also for bad reason. A few words about myself. So my name is Xavier, coming from Belgium with my nice accent in English. I'm known on Twitter, Xme. I tweet a lot. I tweet way too much from time to time. So basically on my day-to-day job, I'm freelance. I have my own company doing some malware analysis, investigations, DFIR, forensic, and so on. And I like to hunt bad guys. So I'm not an attacker, I'm a defender. I'm on the blue team side. Based on this, I'm also a senior handler at the Internet Storm Center. So I hope that you know the Internet Storm Center, where we try to provide a lot of content, diaries, the daily podcast from Johannes and so on. And I'm also a science instructor, so I'm teaching 4610, which is malware analysis and reverse engineering, typically the topic of today. And besides this, I'm also a co-organizer of the Bruckon Security Conference, that you organize in Belgium. This year will be the 15th edition already. 15 years that we're involved in this. So if you don't want to do the last week of September, we will open shortly the call for paper. You are more than welcome to submit and maybe visit us in Belgium. We will enjoy a lot of funny times. So the idea behind this talk, I like to hunt. So as I said, I'm always looking for new trends, looking for new material, because it's part of my Internet Storm Center job. I like to find new trends. And one day, so it's already, I think it's more than 1 year ago, I started to have a look at the malicious Python script. And you see that there is a clear trend. So basically, it's an extract from my database of samples. And you see that, the red arrow keeps growing. This graph is pretty old because it's not a brand new presentation. I already did it several times. And the first time it was 1 year ago approximately. So maybe this value are outdated. Maybe the red arrow is growing like hell like this. Honestly, I don't know. I should try to find some time to update it. But 1 year ago, we had a clear trend regarding Python malware. And so why this talk? If you have a look at the Internet Storm Center, before this talk, we already provided a lot of content regarding Python. So for example, Python abusing the Windows GUI, dangerous Python module, Python masscan, and so on. And some of them were pretty old, 1 year ago, 6 months ago. So it means that it's 2 years ago. So I said, if we have so many attractions regarding Python, why not have a look deeper and see how the bad guys abuse Python? Where do you start when you have to investigate and you are looking for fresh meat? Honestly, I'm the lucky owner of a VirusTotal Pro account. So it means that I can do a lot of stuff like write Yahoo. So you can hunt on VT. The biggest issue with VT is if you get a free account, you cannot access this kind of nice feature. You cannot download samples. and also it's pretty expensive. So if you are you don't have a company, or if you have a very small company, it's pretty expensive to get an account to VirusTotal. But if you have one, you can start to write this very simple YARA rule. So basically, I was looking for interesting strings in files, but I extracted the P file, the DLL, ELF, Android, and so on. I tried to focus on new files where a score very low, so it must be positive, at least positive, so more than one AV should detect it as malicious, but also very small size, because usually Python scripts are very small. So that was my initial YARA rule. It improved in time, so it's slightly different these days, but you get the idea. First, also regarding malware, you have to know that for many people, so the first talk was really interesting. I really enjoyed the first talk, really, really nice. So a lot of people think that malware is automatically a P file, an executable file. It's not true, because most of the time when you get infected by a malware, you have different steps, and it's going like this on the right side of the slide. Usually it starts with a phishing attack or social engineering attack. Oh, this is a nice email. There is an invoice. Please open this invoice, or please visit this website, and so on. That's what we call the first stage. And usually you get a dropper, you get a downloader, which is most of the time a script. We have VBA, JavaScript, VBS. It could be a CMD, so a bash file, could be PowerShell, of course. And this first stage, the goal is to drop something else which is much more malicious. And the second stage usually is a P file. And you will get a nice ransomware, a Trojan, remote access tool, whatever you want. PowerShell remained, and still today remains, the number one. By the way, I saw this morning that attackers, they try now to abuse some more Microsoft product, because you can get OneNote files containing malware. Pretty cool. I really like this. So PowerShell remains the number one. And I like this statistics. 38% of incidents involve PowerShell. 68% of breaches involve PowerShell. So PowerShell is everywhere. It's really cool. But there is something besides PowerShell. And the biggest issue with PowerShell is that it's really popular. So people will get a look at PowerShell. Python, it's not so, it's not the same case. But why attackers decided at a certain point to get more attention to Python? First, it's very popular. It's very easy to learn. In many schools, many universities today, people, they start to learn Python because it's very simple. Some people say, yeah, but we can also use Perl. No flame war, please. I wrote a lot of Perl script in my previous lives, but Python is really one of the top languages today. Really powerful, as I said. So you can start very slowly, you can write a very simple script, and suddenly you can switch to something which is much more complex. You can interact with a lot of operating system capabilities. You can do everything you want. Also, a good point is that many people write third-party libraries. Why reinvent the wheel? Just go to ppy.com.org, I'm not sure about the URL, and you can probably find a library that has already been published by somebody to do some specific action, and we will cover some very nice example. It can be compiled. So if you like to produce a P file, you can go from Python and generate your P file. So by default, it's interpreted, but you can compile it. And of course, less attraction from defenders. Of course, no MSCI support. MSCI support was already mentioned during the first talk. It's a very great feature provided by Microsoft. So the MSCI means anti-malware scan interface. It's a framework, and honestly, good job, Microsoft, because the way it works, basically what you do, you can pass some content of scripts to the MSCI interface, and the primary goal is to detect if it's malicious or not. But in my case, from malware analysis point of view, I use it to trace and to log all the actions performed by script. So if you get a piece of JavaScript, usually JavaScript is heavily obfuscated, and to avoid this very annoying step to try to understand the obfuscation technique, you just execute it in your sandbox, you run MSCI, and bing, you will get a lot. MSCI works with VBS, VBA, JavaScript, PowerShell, but guess what? No, not Python. So it's also a very good idea to use Python, because you will not be able to trace everything using MSCI. Another very good point. The first issue that a malware attacker, a malware developer may have is Python is not installed by default. So if you have a very nice piece of Python script, you deliver it to your user. Most of the time, if the user double click on the file, it will just say, oh, sorry, I cannot open this file. So please select your best viewer. People will do Notepad, whatever you want. So Python is not installed by default. Guess what? If you don't have Python in place, just install it. And Python is embedded in many interesting tools. For example, if you use OpenOffice, OpenOffice comes with a Python interpreter embedded in the installation. If you deploy Splunk, Splunk comes with its own instance of Python. So you have multiple ways to have Python already installed, maybe on some computers. WSL offers also Python. Today you can have something like you can work on the Windows subsystem Linux, WSL. You can have a Linux embedded to your Windows, and guess what? Python will be installed and will be available. Also, that's the other way around. From an attacker's point of view, sometimes if Python is installed by default, it may be a good sign that I'm not targeting the right computer, because I'm targeting a computer used by a high-profile user. Could be a sysadmin, could be a security researcher, could be a sandbox. For example, when you run a sandbox like Cape or Cuckoo, they run a Python script, which is the agent, and in Python script makes the connection between the sandbox and the Cape or the Cuckoo instance. So a lot of malware do, oh, I see a Python script available, or I already have a Python process running, do not infect the computer. First example, it was a quick introduction. The rest of the talk will be only very stupid, very nice, exciting, very powerful, nasty example of what I discovered in my research. The first thing, it's just a simple remote access tool which dropped its own Python. So what I said, if Python is not installed by default, not a problem, just install it. So we have here a piece of interesting code. So we call a PowerShell, and we download from freeze.ga, we download python-389 blah, 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 embedded.zip, and it will be installed on the computer. So that it will be the first step performed by the attacker. No Python, no worries, I will install my own copy. Cool. And indeed, you can install Python very easily, because what we saw here, this interesting file, Python 3.8.9, blah, 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 and so on, it's not a malicious file. This file is available on the Python website. You can download a Python in a few seconds, and everything is embedded. You have a nice package, you unzip it, and you see on the left side of the screen that you have all the required material to install Python in a few seconds on a computer. Cool. It's safe. It's coming from an official website. So why an AV should trigger something? Pretty cool. Of course, when you start to have a look at Python script, you have a lot of obfuscation techniques. It's one of my favorite topics. I like to detect obfuscation or to understand the magic behind this. And sometimes, honestly, respect for some developers, because when I see the imagination, the magic they produce is really nice. Sometimes you can have this kind of idea. For me, the quality of obfuscation equals the quality of code, and also you can have a good idea about the developer's quality. Some people are really script kiddies, they do pretty bad stuff or very stupid stuff. Sometimes it deserves really to be investigated. But the common techniques remain always the same. You have a lot of random variable names. You get variable names like this with completely random characters. You have a lot of base64 encoding, XOR encoding, but also you have a lot of other ones. Hex encoding, characters encoding. Have a look at the title of the slides. Pretty easy to understand, but you can see exactly what can be implemented at obfuscation level. This is an example. You import C types, so you import the library C types, but you can import it as a specific name. So what you do, you import it as I don't pronounce this wonderful string, and then you have a first definition, another one, and you see that when you read this for the first time, your eyes will cry. Oof, come on, how can I understand this? But you can spot interesting strings. WinDLL kernel 32 RTL move memory, create thread, wait for single objects. So basically, this simple script does code injection and then create a thread and boom, start the shell code. But when you see this for the first time, but it's pretty easy to understand. Sometimes it's also very stupid. Probably you know CyberChef. CyberChef is a very nice tool that you can use to play with strings. You can decode them, decrypt them, deobfuscate them, and so on. So when I met this for the first time, I said, whoa, you see in CyberChef on the top right side, you see something which looks like a bunch of base64 because you recognize the characters, the strings ends with the 2 equal sign for the padding. So, okay, no magic, it's base64. So you try to decode this, and then CyberChef just return data is not a valid byte array. It fails. Why? It's a very stupid trick. Have a look at this. That's what I found in the script. Data equals blah, 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 this wonderful base64 string. But have a look at the second line. Data equals data between square bracket 2, colon, len, and so on. If you work in Python, you know what it means. Basically, data, they will skip the 2 first DD characters to make the string completely deobfuscatable. It's stupid, but it works. If you don't pay attention to this and you're not very skilled, okay, it's another type of encoding, I don't know, but no, just remove the 2 first characters. Bing, done. Of course, you have, as I said, Python has a lot of third-party libraries. Some of them are really cool. Some of them are developed by other script kiddies, by students, so they don't have all the same quality. But sometimes you will find very interesting piece of code. The community behind Python is crazy, really crazy, of course, because the language is very popular. So more and more people are attracted. Some people start to work to create new libraries and so on. It's ongoing like this. If you like to access the registry on Windows, you have a look on the right side. I don't know if it's readable for everybody, but the slides will be available, so no worries. You can import rinreg, and now you can access all the registries from Windows. So even if it's Python, you can access registries. And for malware, registry keys are pretty interesting. To implement persistence, to have a fileless malware, you will store some payload in specific keys and so on. So really, really cool. Import rinreg, and it's done. Any API call can be used from Python. We saw this morning during the first talk that we have a lot of interesting API calls. You have all the ZW, blah, 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 the RTL, blah, 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 all it has been covered this morning. You can use them from Python. So you import C types, and you see that the example that my example, I just call virtual alloc, and I'm allocating some memory, which is, then it returns the address of the memory that has just been reserved in the system. Easy, 2 lines. What about recording keystrokes? A keylogger. You can achieve a keylogger in Python in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. Keylogger, boom. If you have a look on, sorry. The keylogger is on the right side. It's even better. 1, 2, 3, 4 lines. 11 lines on this one. You will just use the microphone of the computer and record a WAV file. So basically, you will listen, you will spy to the victim in 11 lines. The result on the disk will be test.wav, which contain my conversation, and then you can exfiltrate the data. You can send it to C2 servers, drop it to Dropbox, whatever you want, and you exfiltrate maybe interesting conversations. Once again, the issue that the malware developers have, Python is not installed, install Python. But all these libraries, they are not installed by default. So it's, once again, a chicken and egg issue. If you don't have the library in place, just install it. So what you do? Try to import some libraries. So you have try except. If you have a module not found error, what you do, you just list the different library that you would like to install. Then you call pip install, blah, 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 and boom. If the computer has an internet connection, Python will do the magic and libraries will be installed in a few seconds for you. So what? Let's do it. Why not call all the .NET framework from Python? It's the same. So this example is the same. So what does it mean? We have a shell code and so on, but it's using Python. And we have a wonderful Python.NET, Python.NET library, which does all the magic. So you just need to use it, and you can use all the .NET capabilities from Python. Another way to use any API. So you can use C types, but you also have Win32 API. Exactly the same capabilities. And what we do, you call Win32 API, for example, open process, blah, 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 and you get a handle on the process. And based on your process, you can do process injection, process allowing, whatever you want, exactly like in a normal language. So PyWin32 is a very interesting library. I already mentioned C types, exactly the same. So you see that the difference between the two slides, I'm doing exactly the same. So I try to open a process, but using a different library in 2 lines. Very, very, very easy. A simple backdoor. If you are a pen tester, red teamer, you like backdoors, of course. 1, 2, 3, 4, 5, 7 lines. And I changed slightly my slide. So still a few months ago, the VT score for this script was only 2/59 antivirus. And it works pretty well because you see that we duplicate the file handle, so it handles stdr, stdin, stdout, everything. You get a wonderful shell. So in 7 lines, easy. Shellcode injection. So once again, so this one is what's the goal? So we use C types. You see that we use URL lib3, so we can do some interesting HTTP requests. And you see that we try to get some information from very interesting website. You do the request, so you get the shellcode from an HTTP request. Then you allocate. You use, if you are a reverser, you know that when you have virtual alloc and the flags 40, it means that we will allocate page execute read write. So we will allocate some memory which will contain executable code. Wonderful. Then we do an RTL move memory. We populate the new memory. We create a thread, wait for single object, and boom, we launch the shellcode. Easy. Another one. This one is a little bit complex, and this one you see that you have also obfuscation because you have interesting function names, interesting variable names. We also have some randomization of strings and so on. So but the goal is the same. You see, you have once again virtual alloc, once again move memory, create thread, blah 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 blah, and nothing special. And you see that when you have the port 4444, probably we have some kind of metasploit behind the attack. Bitcoin stealer, very nice also. When I say that you can access all the features of the operating system, the clipboard is also very popular. What do people? They copy password into the clipboard, but they also copy Bitcoin wallets, of course, because if you have to type your Bitcoin wallet in a string like this, you use it using the clipboard. And what this wonderful piece of malware does, it monitors the clipboard, and if one of the address is found, so you see that it tries to detect if we have a Bitcoin address, and if it's the case, it will replace it by the Bitcoin wallet of the attacker. So if you try to transfer some money, so I transfer some money to you, you give me your Bitcoin wallet, it will be replaced by the one of the attacker, and the money is gone. Easy. Dropbox. Just the presentation before myself, so we talk about APIs. Dropbox has an API, so there is a library, import Dropbox, which allows you to talk to the Dropbox API and do any operation on your Dropbox account. So why reinvent the wheel? If you'd like to exfiltrate some data, some people say, yeah, let's start to have a C2 server located in a so we will first compromise a WordPress account, then we will have some files there, we will have the C2 running on this server. No, just use Dropbox, because first, it's much more difficult to spot and to block inside your organization, because if you decide suddenly, okay, I will block any communication to Dropbox.com, probably you will upset some users. So let's do this. You just define your access token based on your Dropbox account, and you can just send interesting information to Dropbox in a few bunch of lines. Crypto miner. If you can steal some Bitcoin wallets, you can also start your own crypto miner. So this is a pretty simple shellcode. So what it will do, it will generate a new Python file, which will contain, it will also add to startup. So it means that persistence will be implemented, and it will run this wonderful command, megad.exe-a script, blah, 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 stratum. When you see this, you recognize immediately that we have a crypto miner. Ransomware. Yes, I found some ransomware written in Python. Honestly, they are pretty simple. They are simple. So it's nothing really difficult, but if you don't have a backup, the result is the same. Even if it's a simple encryption, stupid stuff is the same. For example, I found some very simple ransomware. Instead of encrypting all the files, they just create a 7-zip archive with all your files, and the archive is encrypted using a password like this. So good luck to recover your files, even if it's in a 7-zip archive. So basically, the one that I found is this one. I didn't try to obfuscate the picture of the guy, so it's extracted from the script exactly. A very nice picture, and that's the type of information that you can see. So that's the ransom node. I kept everything like this, so you see nice URLs and so on. And the ransomware is pretty simple. You have an array containing the interesting extension to encrypt, and honestly, this guy is stupid. Because you see that you have .exe. Normally, a ransomware will never target the executable files because you will break your operating system. Honestly, if you encrypt the application, you target the data, but not the program itself. But anyway, .exe was in the list of targeted extensions, and you have a simple loop. So what we do, we scan all the directories, we search for interesting files, ending with this wonderful extension. And if you found one, we encrypt the file, and then we create the readme.txt, which is this file, nice picture, and so on. So very easy to do. It's effective because it works. Python and Discord. Today, again, people, they don't reinvent the wheel. They like to use some interesting service to do exfiltration or to build a botnet. Discord today is crazy. I think that in 99% of the time when I found a malware, so a Python script talking to another external service, it's based on Discord. It's crazy. And the idea is to work on exfiltration. So it means that they just exfiltrate, they found your password, interesting files, and they send everything to Discord. Otherwise, it's a real botnet. So the malware connects to a Discord channel and is waiting for some commands, and depending on the message that has been written on the Discord channel, they will take some actions. Very easy. So Discord is really, really, really interesting. The good point is that Discord is not really used in many organizations. For example, my customers, they don't use officially Discord. People, they prefer to use Slack, for example, at a corporate level. So Discord, if you see some Discord traffic in your network flows, if you don't use Discord as an official communication channel, it deserves to be investigated. Another one, so I continue my investigation. I found plenty of them. This one is a stealer, pretty stupid. It will just steal the Wi-Fi password, and then it will exfiltrate them where does it exfiltrate? Blah, blah. This one is also, it targets a French system because there are strings in French, but so we generate the password, blah, blah, blah. No, it's, I didn't put this, but password I just exfiltrated. Probably this one could be an exercise from a red team. So we try to grab password from corporate laptops and stuff like this. No. Can Python also try to make your life, if you do investigation, you do some malware analysis, can Python make your life more difficult? Yes, of course. Some anti-debugging techniques. First, this example, Python, before infecting the computer, it will build a list of all the processes running on the system. And if one of them is detected, it will just stop and not infect the computer. and just the list says everything. TCP view, Wireshark, Visual Basic, Filler, VMware, VBox, what else? Auto IT, Express, VMXNet, and so on. So if one of these processes is found, it will stop and it will not infect the computer. This one is much more interesting. We talk during the first presentation this morning. We covered DLL injection, how you can remove the API hooking, stuff like this. You have to know that many antivirus, what they do, they inject DLLs in every process. So why not try to list if a DLL has been injected in my process? So when you run Python, what you do, you open the process, your own process. If you do enum process module, so it's an API call to list all the modules. So a module is a DLL. So you see that because you can import and you can use any Windows 32 API, you can do very interesting stuff. So we list all the DLLs loaded in the process. You do a get module file handle, so you get the name of the DLL. And if you have a match regarding one of the wonderful DLL that you have here, maybe the malware, the Python malware, will not infect the computer. So you do DLL hunting also in Python. I like this one. Clock ticks. When you debug or when you play with the sandbox, sometimes, for example, you are in a debugger, you start your debugging session, then you get a phone call, it's time to smoke cigarette, to grab some coffee, so you stop, you are away from your computer, you come back 10 minutes later, but normally a script, when it's executed or when it enters the function will be completed in a few milliseconds. In this example, what it does, it just connects to an NTP server. You have pool.ntp.org. It gets the time. Then you have some information. And at the end of the function, it will do another request to NTP, and it will make the difference between the two timestamps. If the function has been executed in more than this time, probably it's being debugged. And it's a way for the script to understand and to know that something is wrong. I'm being debugged, for example. Or I'm running in a sandbox, or something happened, but it's really nice. And you see that you can also generate some UDP traffic directly in Python. So you open a socket, sockdgram, then you send to, so you generate the NTP request. So this script was really nice because it doesn't use any command, it just generates on the fly NTP request to a specific server. Everybody knows PEPCAC. The problem exists between the keyboard and the chair. Python can also detect if we have a user. So if the mouse is moving. If you use a very stupid sandbox, your mouse will be on the middle of the screen, will not move. Or if you would like to be sure that you are targeting a system that is used by a real user, it's not a sandbox, it's not, so there is somebody behind the keyboard, you can use this so you can get the cursor, so the coordinates of the mouse, and you do this multiple times. If the coordinates change, it means that the mouse is moving, so probably there is a real user behind the keyboard. So you can detect a user presence like this. You can detect the keyboard layout. We saw also no politics here, so you will see Russian, you will see some Ukraine stuff and so on, no politics at all. But it has been found like this, that you have, the situation now between Ukraine and Russia. They wrote some piece of malware, but the goal is to target only specific countries or to target all countries except this one. So using Python, you can, for example, you can do a get system default UI language. And for example, 2052, it's the code page for simplified Chinese. So you can detect if we are using, so in this case, what we see, if you are not targeting, if you are not running on a simplified Chinese computer, we just silently exit and the malware will not run. The second one, you use the get keyboard layout. So it's another API call from Windows, and you verify if you have 0x409 or 419 and you have English RU. So you can detect the keyboard layout of the computer. You can interact with the GUI. Python can create very nice GUI for you. For example, TK. TK is a very nice library that you can use to open a window, create menu, buttons, and stuff like this. So in this case, what we had, I found this interesting piece of Python, and you see that there are interesting Russian characters. And basically, if you translate this, you have w40.title, which is my window title. And if you translate this, thank you, Google, because I don't speak Russian, it tells you that scan completed results. So probably this piece of Python simulates a fake AV, a fake antivirus, and it will tell you, yeah, you are good to go. Your system is free. No problem. No viruses. Click to continue. And then something malicious will happen in the a few seconds after. By installer, as I said, you can install this, you can generate an executable from a portable app. Remember the backdoor that I showed you a few minutes ago? I compiled this backdoor, so I generated a nice executable that I uploaded on VT. Have a look at the score. Only 9. Stupid, huh? Because it's a backdoor, so it's definitively malicious. Only 9 AVs detected this as malicious. People are lazy. So I'm a lazy guy. So if I can automate stuff, I will do. But attackers are lazy too. So it means that you can find, and I will not reveal the URLs and so on, because the goal is to, because you are good guys, but you can find script that will generate a backdoor for you. So what you do, you just run the script. And what I did, you specify the name. So I said it was in the scope of an Internet Some Center. So I put isc-rat.sample. You create your bot token. This is my super secret token. It will create the file, write the file, and you have a payload that you are ready to distribute to your victims. And it has been targeted for you. It has been crafted for you with a nice red ribbon around it. Here we go. Install this. So you can generate payloads automatically from other scripts. That was my last slide. I would like to add another one. Have a look at ChatGPT. It's crazy how you can get very nasty Python scripts through ChatGPT. I did I did not have time to add some slides because as I said, it's not a brand new presentation, but it's crazy how ChatGPT is good at writing Python scripts, definitively. So if you have any question, raise your hand now. Otherwise, I will be available the rest of the day. I'm happy to share with you, and I hope that now you know that Python can be really dangerous also on Windows system. Thank you very much. Any question? No question? Time for food.
Eccoci anche dopo l'ultimo speech prima del pranzo, infatti ecco c'è l'annuncio l'annuncio del pranzo. Claudio, che ne pensi? Io ho trovato...
Io sono rimasto con gli occhi sgranati.
Guarda, conoscevo le potenzialità di Python onestamente perché è stato, penso, il primo linguaggio di programmazione a cui mi sono avvicinato, mettiamola così. Conoscevo le sue potenzialità, ma ti dirò, arrivare a tutto questo non è altro che una conseguenza logica, nel senso che io nel frattempo mi sono preso un po' di appunti, no? Abbiamo iniziato parlando di anche di detection, di offuscamento e via dicendo, ma se con poche righe sono in grado di scrivere il mio codice, di scrivere il mio malware, è facile che riesca a bypassare signal check, quindi una V non cosciente di quello che il mio programma sta facendo, che il mio programma sta facendo, è difficile che venga detectato. Ecco, intanto si avvicina Vanish, che viene ad onorarci della sua presenza. Vieni, accomodati. Oddio! Come possiamo presentarti? Come dire, l'organizzatore? No, intendo. Grazie, uno degli organizzatori, che innanzitutto ringraziamo per averci dato la possibilità di essere qui.
È un piacere avervi.
Noi ci stiamo divertendo da matti, te lo dico, ci stiamo divertendo da matti.
Bene.
E volevamo appunto da te un po' un'opinione di come sta andando. Devo dire, tutto molto interessante fino adesso, spettacolare.
Allora, come ho detto all'inizio, l'obiettivo di questa conferenza è stata dall'inizio non tanto basata su pochino, che così,
okay, sì,
non tanto basata sull'apparire, ma sulla sostanza. Quindi la prima cosa che è stata messa insieme è stato tutto il line-up di speaker.
Perfetto. E devo dire che fino adesso il livello
Fino
è stato
adesso
altissimo.
Infatti,
Altissimo,
e quello è stato
assolutamente.
l'obiettivo è stato quello. Cioè poi uno può dire non c'è una maglietta, non ci sono, però ci sono gli adesivi, però
C'è la ciccia.
poi c'è la birra.
Poi diciamolo, signori, c'è la birra. Quindi shame on you per chi non è venuto. Avete perso l'occasione di avere della birra gratis.
No, però vi ripeto quello che ho detto anche stamattina quando abbiamo iniziato. Allora, uno dei motivi per cui ho deciso di riorganizzare il BSides a Roma è stato perché notavo spesso flame, soltanto gente che si lamentava che le cose non erano come volevano loro, che c'era sempre qualcosa che non andava, e non è questo il senso della community, a prescindere da quale sia.
Non dovrebbe essere, ne parlavamo in apertura con Claudio, giustamente dovrebbe essere un ambiente in cui la condivisione è alla base di tutto,
Cioè,
non
se io
dovrebbe
dico,
esserci classismo.
allora, se io accedo ad un canale, a una community, e faccio una domanda, per quanto stupida, non dovrei essere prima preso in giro e poi data una risposta.
Certo.
Dovrei avere una risposta per dire, guarda, magari
Non esistono domande stupide.
Esatto.
Anche perché chi magari fa quella domanda e viene ritenuta stupida è una persona che in realtà vuole avvicinarsi.
Esatto.
Quindi è comunque un supporto, no?
io noto questa cosa soprattutto in determinate community, ma soprattutto quando uno deve condividere il codice, per esempio. Io ho notato spessissimo, ho parlato con moltissime persone che hanno fatto delle cose fighissime che però non condividono
Per paura
perché nel
diciamo.
momento in cui condividono, il 90% delle persone, prima di capire di cosa si sta parlando e quindi magari dare effettivamente un contributo, comincia a dire ma questo lo potevi fare così, questo lo potevi fare così.
Sono tutti bravi col senno di poi, no?
Quindi allora,
in uno spot pubblicitario fa
l'obiettivo oggi è quello di condividere, punto. Essere inclusivi, a prescindere da
Ed è
tutto.
già di per sé una cosa meravigliosa di cui darvi
Quindi,
veramente merito.
Cioè, questo è stato l'obiettivo di questa conferenza. Non fare flame, non fare polemica, ma soltanto condividere contenuti. E considera che uno degli obiettivi che mi ero posto all'inizio della conferenza è che ognuno dei partecipanti arrivasse al termine della conferenza dicendo il 5% delle cose che sono state dette oggi io non le sapevo.
È un takeaway. Assolutamente.
Se raggiungo questo obiettivo sono contento.
Io devo dire che sono già ben oltre il 5%, lo dico proprio sinceramente.
Vabbè, ma è per
me
quello che ho
tutto-
messo, è per quello che ho messo il primo talk. Siamo andati subito su Windows Internos e siamo a posto.
Approfittiamo, visto che ci sei tu qui, Agostino, c'è anche la CTF in corso.
Sì, c'è
Io ero
anche la CTF.
convintissimo che fossero due eventi separati, non
No,
paralleli.
la
In realtà
la
è già
CTF è in corso, è iniziata stamattina.
Vogliamo far vedere, riusciamo a far vedere dalla regia intanto la classifica mentre noi ne chiacchieriamo? Perché giustamente ci siamo attrezzati, Agostino, siamo attrezzati,
è
siamo
giusto.
sul pezzo.
È giusto.
Però ho visto che ancora nessun team, almeno per quando l'ho vista io, nessun team
ho
ancora
notato
aveva
pure io prima.
iniziato
Ho notato pure io
a
prima.
giocare. Secondo me è troppo presto. Perfetto, eccola qui, la
Sì,
nostra
infatti,
classifica.
Vabbè, vediamo. Allora, intanto vi dico i premi quali sono.
Che insomma mi sembra...
Allora, il team primo classificato ha, per l'intero team, ha la subscription annuale a Ponix.
che io ce l'ho per la collaborazione tecnica con Ponix ed offre tantissimo.
Quindi grazie a Carlo che ha messo a disposizione questo premio.
È ricchissimo, oserei dire
Soprattutto
ricchissimo.
importante è per tutto il team,
Quindi,
non è una per...
ecco.
Mentre gli altri due, il secondo e il terzo posto, hanno dei voucher di Hack5
Ecco, un'altra cosa che insomma
che cortesemente, dopo che io ho chiesto, mi hanno dato i voucher.
molto intriganti anche come cosa. Se scorriamo un pochino più giù la pagina della classifica vediamo
No,
che-
attualmente stanno ancora in corso.
sì, no, a parte volevo invitare appunto tutti i team ad attivarsi perché è arrivato il momento. Se scorriamo, quanti team abbiamo? Vediamo un attimo.
21.
Una ventina,
Sì.
21 team. Andiamo un pochino più giù. Abbiamo ancora a livello di tempo 6 ore e 12, 6 ore e un quarto, quindi
Sì,
veramente
perché si conclude, la CTF si conclude con la conferenza.
con la conferenza, quindi alle 19
Sì,
circa,
esatto.
giusto? 5 sfide, se non ho visto male, sì, 5 challenge.
5 challenge non pubblicate prima,
quindi sono
inedite. Quindi
cioè,
giocate.
è il momento di giocare, il momento
Se
di
no,
mettersi in
se
moto.
non giocate, i voucher me li tengo io e chiedo a Carlo di avere la subscription.
Che non vedo perché no, onestamente.
Altrimenti ci mettiamo tutti qua in team e facciamo...
Lo facciamo noi da qui, lo facciamo noi da qui dalla regia, sì, perché siamo poco competitivi.
Esatto. Sì, sì, no, proprio per niente, guarda.
Sono contento che vi sta piacendo fino adesso la conferenza.
Assolutamente.
Assolutamente.
Nel pomeriggio abbiamo anche altri talk
Di spessore.
e poi vabbè chiudiamo con Viezze che vabbè il maintainer dei LOLBAS.
Ci aspettiamo grandi sorprese.
Quindi
A questo punto direi ti lasciamo andare a pranzo. Andiamo
sì,
a pranzo
anche perché io
un po' tutti quanti.
ho bevuto un po',
È il
quindi
momento di mangiare, è il momento di ricaricarsi. Andiamo in pausa per il periodo del lunch break. Ci vediamo dopo alla ripresa della conferenza e buon pranzo a tutti.
Ciao!
ciao.